echo. So I heard that we've heard some complaints that the audio is too loud here. But since there was just a pretty loud presentation over there, we thought we would try to get somebody's attention. What do you think? Don't just look, come on over here, let's go. All right. I'm sorry, did I break your concentration? That's my job. I'm Dan King with Galaxy Semiconductor, and I wanted to tell you something. That song in this ridiculous suit actually has a meaning. Hey Pete, how's it going? Because we, Galaxy, have recently traveled back from a galaxy far, far away. So what does this mean, very far away? Before I tell you that, let me just tell you who we are, what we do. We design and build software that empowers engineers to understand data, make predictions, intelligent decisions in the design, production, and quality of the life cycle of semiconductors. So how did we come back from a galaxy far, far away? Before we get that, this is always a nice slide that people like to gander on and Google over, but here are some of our over 120 customers, over 8,000 users worldwide, lots of big names up there you probably recognize, just to show us that, you know, we know what we're talking about here, so there's a little bit of clout for us. So what is this galaxy we've come far from? Well, we're almost 25 years old. And over those years, we've launched 3 different products that I'll talk about in just a moment. But in recent years, we were a small little itty-bitty company that was bought by a very big company you may have heard of called Mentor Graphics, who was then 6 months later bought by an even bigger company, Siemens, which you may have heard from. And we were rebranded as Quantix, so you may have heard of that in the industry in the last few years. But 2 years ago, the original owner of Galaxy bought the company back, and we are back to the small, fun, energetic, innovative company that we always were. Thank you. Can you tell we're excited about that? I'm excited about that. You guys feel that? So, in recent years, even as recent as earlier this year, we acquired a company, Epon Innovation, and we'll talk a little bit about that later as well. So let's tell you just a little bit about us, and I'm going to have some fun. We got a big announcement today that I'm going to share with you. And at the end, if you happen to stay to the end, if I don't bore you to death, I'm going to give you guys an awesome invitation to a ridiculous event tonight that it'll be the highlight of your week, I promise you. So first of all, if we look at the life cycle of devices, and we talk about when you get first silicon and you're doing device characterization, or you're ramping into production, or you're already in production, the 3 products that I told you we came out with, I'm just going to go over those very briefly for you. First of all is Examinator Pro. In this is like when you got your first silicon, you're looking at all your characterization data, setting limits, looking at guard bands, looking at gauge studies, you're looking at wafer maps, you're looking at early yield, you're looking at reliability data, you're looking at stacking wafers and Paretos and box plots and correlations, all these different things. This is how the engineers get their job done on a day-to-day basis. And it is the easiest to use software in the industry, even though it is very powerful. Now from there, once you get into production, we had come up with a full enterprise yield management system. Now this is all about gathering data, no matter where it is, whether it's part of APIs or from data streams or from files, and it's gathering this data in an automated fashion. It is not only validating, cleansing, parsing, but inserting this data into a MariaDB database, but it's open. That's the really cool thing about this, is it's an open design. We are not a closed black box, we are not locked up. And you can use a command line interface to interface with this. It's wide open for you. It also gives you all sorts of different automated yield alarms and alerts. Hey, you know what? My product XYZ yielded less than 93%, and I want to know about it right now. Well, here you go. Or I want my weekly yield report done every Monday morning on my desk. There you go. All sorts of automation. There's also advanced algorithms. We'll talk a little bit about this later. That also pushes out all sorts of results in an automated fashion, as well as web-based business intelligence dashboards. The cool thing is, though, the program that everyone is using, Examiner, still talks to this. So you don't have to learn a new system when you're now stepping up to the big boy data with the databases and such. Can you guys hear me okay?
Yeah.
All right. Louder? Oh no. Really? Okay, so once you go to Yieldman, well, you might say, I'm not quite ready for Yieldman. That's okay, because you can have like a standalone database that engineers love this. Pete loves this because he had one in his little laptop in a little lab. This allows you to have a little mini engineering database that the IT people might not really even know about. Or you can also put it on a server and let everybody in the world get at it. It doesn't matter either way. But the cool thing is that you can have this little database, and in addition to doing things with your production data, you can also do extremely deep characterization data. So you can look at all sorts of different splits of fab splits and temperatures, unlimited amount of conditions and levels, but you have the flexibility of setting the hierarchy any way you want, and you have the ability to help extract conditions from test naming or test numbering schemes and actually create new conditions based on those. So it's not, it's kind of rocket science, because it's like, hey, this test name has all these conditions built in, let's extract them with a script. So here we're looking at like fab split and temperature data and gain data, and you might be able to see things really easy, like all these splits, that we can quickly see that, hey, our process is falling over the corner here at this fast slow split. Or you might see, hey, look at this. This one split of M plus is tracking with our nominal, but nothing else is. Why is that? What is going on? Is this frequency is going up, everything's tracking down, but some of this is much different from our nominal data. Or maybe even like, what the heck is going on with this one data point at the frequency of 499 on this specific split? And you can see this very easily by doing this. The next thing that we're going to talk about quickly is PAT-Man, and this is when you may have heard of part average testing. And I'll talk to you briefly about what this is. PAT in general, if you haven't heard about it, is a way to up your game in the reliability. We've seen a lot of presentations about how high reliability data is going huge. The automotive industry is growing, medical industry is growing, but even the commercial industries are starting to do part average testing. And that's where we take something like this blue distribution for wafer number one, let's just say, and you've got some parts, you've got some red limits out here, and we have some parts that are actually good. But because they're statistically different, we don't want them to get out in the field, because these are going to be your return failures that are going to cost you time, money, failure analysis, lots of reports, 8Ds. It's not fun. Believe me, you don't want to be there. So this allows you to get rid of those parts and essentially saving yourself lots of time and money. And of course, you might be doing this with, say, each wafer individually. And that's what part average testing does and what our PAT-Man is. Now this leads right into our one of our big announcements. You may have seen the banner out there in the front. That thing is beautiful. It says, ask us about Orion. So here at ITC, we are announcing our next generation platform in support of advanced analytics. And it's called Orion, because Orion was a hunter. And we are hunting anomalies in space with Orion. So what is Orion? Orion is a data agnostic platform, which is awesome. Galaxy is all about being open. And so it's going to accept all sorts of different formats, like files. You might be familiar with just dragging and dropping files. 150 different formats. Those are all the ones that we already support in Galaxy, whether it's STDF or text, CSV, WAT, log. Data streams. If you have some streams that are coming off the tester in real time, it can gather data that way. APIs that way too. All completely open. And even SQL. Now, in addition to this, we talked earlier about some algorithms, and I briefly talked about how in February this year we acquired EPON Innovation, and it was said at the time that the acquisition brought together EPON's data science expertise, their patented algorithms, and Galaxy's state-of-the-art data management systems together. Now, EPON has been a provider of unique advanced statistics for a while. They've been in both semiconductors, pharmaceuticals, and other industries. We were already working with them for a long time. They were kind of part of our team unofficially, but now they are officially part of our team, which means our industry-leading open algorithms that are not a black box, that you get to actually see what we're doing, and you can change them if you want to, but we give you some great ones. They're now even better than they used to be, and they will continue to get better because of this. And that leads into some things that Orion is going to be used for. One of the main things is high reliability product-based applications. So we just talked about PAT, okay? Now these outliers in PAT are now going to be detected even easier with these better algorithms using Orion, partly by these new algorithms from EPON Innovation. Another way to use this is like a stuck die detector, where you might have a part that's actually stuck in the socket, and a part is being placed right on top of it, and you're continuing to measure something over and over, and it thinks it's a different device, but the data tells us it's not. These are algorithms and ways that we'll be able to help you figure that out and get things changed right away. This next one's a big one, because when you look at different outliers, you might be able to look at things on an individual basis. But what this is going to do is what we're calling omnivariate outlier detection. So this has been proven to significantly help you with customer returns, make sure that they're less. Now, in an actual industrial use case, meaning it's real data, we've been able to find more outliers than the standard method, which is univariate, like one test at a time. So for example, with an unsupervised method, we can look at things that will score things based upon many tests simultaneously. So now we're not just looking at one test and looking at data, we're looking at all the tests simultaneously. From that, coming up with some interesting ways of algorithmically coming up with scores that will help us find more outliers while still keeping your yield down. So this is a huge thing. Another one is root cause identification by using a decision tree-like platform. And think of things like, okay, got a bad yield on this lot. Well, what happened? Well, it was tested at this facility and that facility. Okay, well, let's look at those. Well, let's look at the different equipment this was on. Let's look at the different testers, the different boards, the different sockets, the different operators, the different, you name it. You tend to do a lot of the same analysis as an engineer. The more that you can automate through decision trees will never replace you. We don't want to replace product engineers. We don't want to replace test engineers. We need your human engineering judgment, but we can make your lives easier and more efficient by having decision tree-like algorithms. Another completely different way to using some of the algorithms in Orion is for predictive maintenance for manufacturing efficiency. And so we just talked about EPON Innovations algorithms with our team and with ST Micro and Catania, powered up to evaluate a time series sensor. So this is for like fab equipment processes. So if we look at this, we have basically 1 month data running in production as a piece of fab equipment. I'm not going to tell you which one, see if you can guess it. Now these little pieces over here are little indications that something different is going on. Now again, this is looking at, in this case, it was 34 different parameters measured simultaneously and coming up with a severity score of what might be going on. Now in real life, what happened was something failed. But with these algorithms and with this new omnivariate way of looking at multiple tests at a time, you have obviously things like assignable causes and things like this, but you also have some signals, and then you have a failure. With these algorithms, looking at things in an omnivariate way, even in fab processes and predictive maintenance, you're able to catch a fab equipment failure 3 days before it happened, saving a ridiculous amount of time and money. So that's the announcement for Orion. Now, here comes the audience participation part of the story. I told you if you sat here and you listened to the whole presentation, which you have, thank you everybody very much. Nobody actually got up and left, that was kind of nice. I've got 3 questions for you. It's very important, this is a quiz. See if you were paying attention. I'm just kidding, it has nothing to do with what I was talking about. 3 questions for you, they're very important. If you know it, just shout it out, okay? First one, what do you call a pirate that has both eyes and all 4 limbs? A pirate with both eyes and all 4 limbs. No, what? A sailor, no. The answer is a rookie. A rookie. Next question, I got 2 more. There's plenty more where that came from. The second one is, how much did the pirate pay for his piercings? How much does a pirate pay for his piercings? I see people thinking. I see smoke out there. You guys are thinking hard. People are Googling. Hey, put your phone down. All right. No? What's that? Very close. He said $1. That's actually pretty good. We should give him a gift. Tonight, show up and we're going to give you a special gift. It's not $1, which is good. It's a buccaneer. A buccaneer. You got it. Okay, last one, and then we're going to give you the invitation. Why did the pirate go to the Apple store? Why did the pirate go to the Apple store, folks? And I'm not talking about a grocery store. Why did he go to the Apple store? Anyone? He had to get a new eye patch. Oh, a new eye patch. Now, why are we doing this? Give me just a second. Wait for it. a space pirate now, watch out. Because tonight, we want you all to come up. We have the Pirates of the Caribbean suite. We're gonna have a party. 7:30 to 10 o'clock. Take a picture of this with your phone right now so you don't get lost tonight. And take a picture where you're coming from because you're probably gonna be stumbling back. But anyway, 7:30 to 10 o'clock tonight, we're at the Pirates of the Caribbean suite in the Adventure Tower. It is room 2936.
What room?
2936, the Pirates of the Caribbean suite.
Top floor.
Top floor of the Adventure Tower. Come tonight, 7:30 to 10. It's gonna be crazy fun. We got games that we're gonna be playing. Galaxy folk are gonna be dressing up like pirates. No costumes required to come. We have some concoctions that were specifically designed for this event that have interesting names and looks and glitter and all sorts of stuff. And we got some pirate games, and you'll get a pirate name tag depending on your name and the month you were born in. It's gonna be a blast. So thank you so much for your time tonight, 7:30 to 10. This has been Dan King, Galaxy Semiconductor. We'll see you tonight. Party!